Ladies and gentlemen, good morning to you in Taiwan and good evening to you in the U.S. And welcome to the 2022 Taiwan-U.S. Intelligent Manufacturing System and Robotics Summit. Now, ladies and gentlemen, our speakers today will be talking about the issues of advanced robotics technology. Now, this can be incorporated to take smart manufacturing and digital transformation to the next level. And together, U.S.-Taiwan, we will be exploring more opportunities for more cooperation between Taiwan and the U.S. And we will be navigating through an entirely new supply chain. Now, as we all know, Taiwan has very good machinery robotics components and precision instrument fundamentals, whereas the United States of America has very strong capability to integrate smart systems, including artificial intelligence, AI, robotics platform. And so, in order to ride this wave of industry upgrading opportunities, we should form alliances to quickly provide solutions to our consumers and to adapt to the market changes and market needs. So, ladies and gentlemen, this forum is a continuation of last year's October MOU between Taiwan and the United States. And today, we are inviting experts from all over the world to discuss and to interact and to promote Taiwan and U.S. collaboration in this area of smart manufacturing and robotic supply chain to create a win-win situation and business opportunities for both Taiwan and the United States. So, ladies and gentlemen, without further ado, now we will have the opening remarks, and to begin, I would like to first welcome Director General Mr.呂正华局长from the Industrial Development Bureau, IDB, of MOEA, which is Taiwan's Ministry of Economic Affairs, which is promoting the industrial cooperation and strategic partnership between Taiwan and the U.S. to give us the opening remarks. Director General, Mr. Lü, please.
Okay. Deputy Secretary Briel of Pennsylvania Department of Community and Economic Development, Commercial Officer Bureau of AIT, Director Golan of Commonwealth of Pennsylvania Trade and Investment Office in Taiwan, Deputy Director General Go of ISTI E3, and Manager OSHA of Pittsburgh Robotics Network. Ladies and gentlemen, good morning and good evening in the United States of America. The global economy has changed rapidly in recent years. From the U.S.-China trade and takeover in 2018 to the outbreak of the COVID-19 in 2019, the rebuilding of the global industry supply chain in 2020 has greatly impacted companies in production, marketing, global supply chain strategy, and factory operation management. Moreover, the high inflation rate as well as Russia-Ukraine conflict in 2022 have not only triggered gas price up to a record high in the U.S., but also resulted in global raw materials, energy, and food prices, which challenges enterprise, especially manufacturer, in risk management and the ability for digital transformation. The digital transformation driven by COVID-19 pandemic has increased the demand for remote cooperation and automation, as well as value-added service such as 5G and AI technology. According to TrendForce research, the global smart manufacturing market will grow up from $305 billion in 2021 and expected to reach to $450 billion by 2025, with a compound annual growth rate of 10.5%, which will usher in golden 5 years for manufacturing industry. It is believed that the benefit of smart manufacturing has shifted from simply enhanced manufacturing resilience to increasing production capacity and efficiency, energy saving, emission reduction, which have become critical elements to boost the growth of the market. Taiwan already has a good foundation for machine tool and precision machinery, and the U.S. has always had advanced development of software technologies such as intelligent system integration, AI software, and the collaborative robot platform. The partnership between Taiwan and the U.S. could create extra value chain for the emerging marketing. The Industry Development Bureau, IDB, of the MOEA Taiwan has initiated the Smart Machinery Industry Promotion Program and the Statue for Industry Innovation since 2016 that help industry moving toward the global of making Taiwan an Asia high-end manufacturing center. And last October, we are glad to witness the industry cooperation MOU signed by TUSA, Tyro, and the PRN. And now on this platform, we are connecting clusters for exchanging thoughts and exploring more business opportunities and strategic partnerships. I'm pleased to be here for the 2022 Taiwan-US Intelligent Manufacturing System at the Robotics Summit. My best wish to this great event a total success, and to all my friends with great health and prosperity. Thank you all. Thank you very much.
Thank you so much to our Director General, Mr. Liu. Thank you for the wonderful opening remarks. Next on, ladies and gentlemen, we are now inviting Mr. David Briel, the Deputy Secretary from Pennsylvania Department of Community and Economic Development, which is supporting this event. Please, your remarks, sir.
Thank you. Thank you, everybody. Good morning to everyone in Taiwan. On behalf of Pennsylvania Governor Tom Wolf and our Department of Community and Economic Development Secretary Neil Weaver, it's great to be a part of the 2022 Japan-U.S. Intelligent Manufacturing Systems and Robotics Summits. I thank Director General Liu. Also James Guo from ITRI, who I've had the opportunity to visit ITRI a number of times in Taiwan. Spectacular stuff going on there. As well as I'd like to say special thanks, of course, to Jimmy Liang of TUSA, and particularly Vicky Sun for her work and patience in putting this all together this evening. It's thanks to her efforts that we're all able to come together this evening. I'd also like to recognize our own Pennsylvania partners who will be on this evening from the Pittsburgh Robotics Network, as well as Carnegie Mellon University. We're proud to be able to bring concrete to the MOU that was signed last year, and we remain closely connected with the Taiwanese business community. Trade in Pennsylvania and Taiwan continues to grow, particularly in manufactured goods. We now own about $1.2 billion a year. It's going back and forth between Taiwan and Pennsylvania every year. We recently announced a direct port to port, Port of Philadelphia to Port of Kaohsiung connectivity, which I think will help in that two-way trade. As well as we see a number of Taiwanese companies that have set up shop here in Pennsylvania in the manufacturing, which is companies like Omahai, Fusheng, which is compressor manufacturing in Pittsburgh. Those companies are an integral part of our cooperation with Taiwan. And we look forward to working with more as events like this introduce us to new Taiwanese companies who are looking at opportunities in the United States. And Pennsylvania, given its leadership and because of Carnegie Mellon and other universities and research institutes in robotics, in manufacturing, is a natural home for Taiwanese companies to look in North America. I'd also like to take this opportunity to it was brought up a few moments ago that Pennsylvania has reopened our office in Taipei. Liran Golan and Nancy Yang are on this evening, and they were a big part in working with Vicky to put this event together. They work basically on two things: helping Pennsylvania companies sell products, service, and technologies to Taiwan, to Taiwanese companies, as well as they're there to help Taiwanese companies look for investment opportunities here in Pennsylvania. This is an integral part of Pennsylvania's strategy with Taiwan, and the summit this evening is another piece of us helping to grow closer in our economic collaboration. So again, I'd like to thank the organizers. Thank you to TUSA and the MOEA for their efforts this evening. And we look forward to working with you. And hopefully, we were planning to go to the U.S. Business Day in Taipei this year. Unfortunately, that's now been made virtual, but we will be participating. Our secretary will be participating in that event with MOEA. But hopefully we can get to Taiwan again soon. And we look forward to seeing some of you here in Pennsylvania. So thank you very much for this opportunity. And I wish everybody a successful summit. So thank you.
Thank you, sir. Thank you to Mr. David Briel. Thank you for joining our Taiwan-U.S. Intelligent Manufacturing Systems Robotics Summit. Taiwan and U.S. are good friends, and we have wonderful cooperation. Moving on, ladies and gentlemen, now I would like to welcome Mr. Clint Brewer. He is the Commercial Officer of American Institute in Taiwan. He is a part of our core team leading this transformational export program within the global markets. Ladies and gentlemen, let us welcome from AIT.
Great. Thank you so much, sir. Director General Liu of IDB, Representative Golan of the Commonwealth of Pennsylvania Trade and Investment Office in Taiwan, Deputy Secretary Briel of the Pennsylvania Department of Community and Economic Development, Mr. O'Shea of the Pittsburgh Robotics Network, General Director Yao of the Mechanical and Mechatronics Systems Research Labs at ITRI, Deputy General Guo of ISTI at ITRI, distinguished speakers, online guests, ladies and gentlemen, 早安, 晚安, good morning and good evening. My name is Clint Brewer, and I'm a commercial officer in the commercial section at the American Institute in Taiwan, also known as AIT. I'm part of the core team in our organization leading the Transformational Exports Program, which helps U.S. exporters access new markets across the Indo-Pacific region in critical high-tech sectors, including advanced manufacturing, automation, and robotics. It's an honor for me to give remarks at the 2022 Taiwan-U.S. Intelligent Manufacturing System and Robotics Summit. I still have a vivid impression from the Taiwan-U.S. Smart Manufacturing Summit that was held last October, when together we virtually witnessed the MOU signing ceremony between TUSA, Tyroa, and the Pittsburgh Robotics Network, or PRN. I want to thank everyone for their contributions and their efforts to promote bilateral cooperation on advanced manufacturing and intelligent manufacturing systems, automation, and robotics. And for those who may not be aware, my organization, the U.S. Commercial Service, is the export and investment attraction arm of the U.S. Department of Commerce. And our aim is to help American companies access new markets around the world, while at the same time attract high-impact foreign direct investment into the United States. In Taiwan, we have a commercial team comprising 22 staff members split between our AIT offices in Taipei and Kaohsiung. And I'd like to thank TUSA and Tyroa for being remarkable partners to AIT and to especially our section, the commercial section. Over the years, we've collaborated on numerous impactful projects and initiatives to promote bilateral trade and investment between the U.S. and Taiwan. For example, in 2018, TUSA and AIT led a trade mission to Pennsylvania that traveled all the way from Pittsburgh to Philadelphia to promote bilateral trade, investment, and technology cooperation. And we hope that our teams can collaborate on a similar trade mission in 2023. And speaking of Pennsylvania, it's remarkable how the Keystone State has created state-funded programs such as the Manufacturing PA Innovation Program to connect academia with industry and facilitate growth in the advanced manufacturing sector. The United States has a great partner in Taiwan in this sector. As one of the world's most important ICT manufacturing hubs, Taiwan is a regional high-tech supply chain center due to its advanced R&D capabilities in semiconductors, 5G telecom, and other ICT-related fields. I believe that the U.S. system integration and automation solutions are complementary to Taiwan's strengths in the above-mentioned areas. In terms of upcoming events in Taiwan, my team is looking forward to participating in Automation Taipei 2022, which is the biggest automation show hosted by Tairoa. It will be taking place from August 24th through the 27th. And then Semiconductor Taiwan is one of the most important semiconductor shows in the world and will be held from September 14th to the 16th in Taipei. Semiconductors, as you all know, is the epitome of applying all sorts of intelligent manufacturing systems, automation, and robotics into one industry output. Moreover, I would like to acknowledge the team at U.S. company Rockwell Automation, which is a longtime client of the U.S. Commercial Service and AIT, and from whom you will be hearing from today during this summit about their smart manufacturing solutions that they're offering in Taiwan. So in closing, let me say we are fortunate to have with us today some of the most forward-looking businesses in the world working on advanced manufacturing, automation, and intelligent manufacturing systems. I have every confidence that the U.S.-Taiwan cooperation will be successful and a strategic goal to restructure global supply chains and expand bilateral industry collaboration. Thank you very much.
Thank you, sir. Thank you to Mr. Clint Brewer. Thank you to AIT. Yes, Taiwan and U.S. are great partners. It has been in the past, it is still now, and we will take it many steps further into the future with our summit. Next, ladies and gentlemen, we're going to hear from Mr. Guo. He is the Deputy General Director from Industry Science and Technology International Strategy Center, which is abbreviated to be ISTI. This is a part of Industrial Technology Research Institute, ITRI. So now, without further ado, let us welcome Mr. Guo.
Thank you, Andy. 工业局吕局长 Deputy General Briel of Pennsylvania's Department of Community and Economic Development, Commercial Officer Brewer of AIT, Dr. Golan of Commonwealth of Pennsylvania's Trade and Investment Office in Taiwan, Manager O'Shea of Pittsburgh Robotics Network. Ladies and gentlemen, good morning and good evening to the friends from the States. On behalf of Industrial Technology Research Institute, it is my great honor to welcome you at today's online event. First of all, I would like to present an overview of ITRI, as our friends from the state may not be familiar with us. ITRI is one of the world's leading applied research institutes with more than 6,000 outstanding employees. The institute was founded in 1973 to innovate a better future for Taiwan. For 14 consecutive years, ITRI has been a winner of R&D 100 awards and has been named 6 times one of the world's top 100 innovative institutions. Fulfilling the vision set by our former chairman, Dr. Maurice Chen, ITRI is proud to be among world's leading R&D organizations. Over the years, ITRI has been dedicated to nurturing numerous key forward-looking technologies and incubating startups and spin-offs, which include world's most innovative champions such as TSMC, UMC, Epistar, just to name a few. It has been giving birth to a total of 244 successful enterprises. Digital transformation and the smart factory are global trends that drive the rapid economic growth, which require a high degree of cross-domain technology integrations. To take on the challenges and opportunities, ITRI is committed to working closely with its domestic and international partners to create new value, identify unmet technology needs, and actively promote cross-domain collaboration for innovation and industrializations. We are thankful for today's event, which enables us to connect with well-known clusters in the United States in times of the pandemic. We hope this event will open doors for further discussion on possible cooperation and strategic partnership. I sincerely wish the event a big success. Thank you.
Thank you, Mr. Guo. Thank you to ITRI. Now, ladies and gentlemen, this is a moment to remember, so we are going to take a group photo right now. So, inviting our distinguished guests to join us for this wonderful group photo, we have already online Director General Mr.呂正华局长from Industrial Development Bureau, IDB, MOEA. We have Mr. David Briel, Deputy Secretary of Pennsylvania Department of Community and Economic Development. And joining us right now, we also have Mr. Liren Golan, the authorized representative from the Commonwealth of Pennsylvania Trade and Investment Office in Taiwan, together with her team. And welcoming Mr. Clint Brewer, Commercial Officer, AIT. And we have many guests for this wonderful group photo. So when we do the group photo, we smile to the camera. Give us your best smile. If you have your face mask on, take it off for a few moments. And then we will do a screenshot. So you need to hold your smile for a few seconds, just a few seconds only. More guests, including Mr. Darren Yao, the General Director of Mechanical and Mechatronic Systems Research Labs, also part of ITRI, welcoming Mr. James Guo, the Deputy General Director, who just spoke to us from Industry, Science, and Technology International Strategy Center, also from ITRI. And we have keynote speaker, Mr. Charles Tam, Country Manager of Rockwell Automation Taiwan. We have George DeRocas, Chief Partnerships Officer from the School of Computer Science, Carnegie Mellon University. Please do join us for the group photo. You must have your camera on. And welcoming Mr. Nick DeSanti, Business Development Manager, Carnegie Robotics. Jonathan Hurst is joining us, Chief Technology Officer from Agility Robotics. And last but not least, Mr. Jimmy Liang, our Executive Secretary from Taiwan USA Industrial Promotion Office, MOEA. Now, let's do this group photo. Smile towards the camera. If you have a face mask on, take it off for a few moments, please. Okay, look into the camera with a smile. And we'll do the screenshot. Hold your smile, please. Very good smile, hold it. We're done with the screenshot. Now, second photo, if I may. Thumbs up. Thumbs up for our forum. Thumbs up for the friendship, partnership, and collaboration and cooperation between Taiwan and the United States of America. Okay, thumbs up with your smile, of course. Hold your pose. Hold your position for a few seconds. We're doing the screenshot. Just a few more seconds. Thank you so much. Please bear with me. We're doing the screenshot right now. I'm waiting for the cue that the screenshot has been done. So please hold it for just a while. Okay, we're done. Thank you so much. Thank you for your cooperation. That was a wonderful group photo. Now, moving on with our summit, the first keynote speech for today is from George DeRocas, Chief Partnerships Officer, School of Computer Science from Carnegie Mellon University. Please give us an introduction of research development overview of CMU and partnership opportunities with CMU. Welcoming Mr. DeRocas. Please.
Thank you very much. It's so nice to be with everybody this evening. Again, I'm George DeRocas. I'm the Chief Partnerships Officer at Carnegie Mellon's School of Computer Science. I'm really excited to be here tonight. Wanted to tell you a little bit about Carnegie Mellon and look forward to many fruitful partnerships in the years to come. So this is just the start. So Carnegie Mellon, if you could go to the next slide, Vicky. Skip to the next one as well. So Carnegie Mellon is known as a university of many firsts in computer science. So very first computer science department, machine learning department, robotics department, and is classified as an R1 doctoral university with very high research activity. So one of the top research universities in the country. The city of Pittsburgh is where the main campus is located. We also have campuses around the world in Doha, Qatar, Rwanda, and then we have many master's program exchanges with other universities from around the world. There are about 14,000 students that make up Carnegie Mellon University and about 1,400 faculty. So the split here is about 50-50 at undergraduate to graduate level. So about 7,000 undergraduate students to about 7,000 graduate level students. That's master's and PhD. If you could skip to the next slide. So as I was saying earlier, there are many firsts that Carnegie Mellon's very proud of, going back to the late 50s with artificial intelligence, where our founders, Herb Simon and Alan Newell, showed up at the very first Dartmouth conference on artificial intelligence with a working program called the Logic Theorist. So everything from multi-core processing to the mock kernel that sits on your iPhone, to autonomous robots. One pictured here in 1983 is still encased in 3 Mile Island, which is a nuclear plant here in Pennsylvania that was there to help with the cleanup from that near disaster. Towards in 2007 here, autonomous vehicles. So a lot of the early industry and early research on autonomous vehicles was done here at Carnegie Mellon to cobots, founded by Manuela Veloso, who is a longtime faculty in our computer science department. This is back in 2014, where these autonomous robots would navigate the halls of Carnegie Mellon, delivering things to people around the computer science department. If you could skip to the next slide. So a lot of number one. So CMU for many years has been ranked as the top school for computer science, tied with MIT and Cal Berkeley and Stanford. So very strong in artificial intelligence and cybersecurity, programming languages. These are all just examples of strengths that CMU is known as the top university in the country in these areas, as well as many number twos. Also very strong, not just in computer science and engineering, but also in the arts. And some of the awards on the right there show some of the work that's done with the arts, which is very important at Carnegie Mellon, because there's a lot of multidisciplinary work that spans the technical and the arts, the design and technical. If you could skip to the next slide. So Carnegie Mellon is comprised of 7 schools and colleges that make up Carnegie Mellon. The most technical are the College of Engineering, where you have a lot of traditional engineering departments, like mechanical engineering and chemical and civil and environmental. And the School of Computer Science in red there is where I'm located. It's one of the things that makes Carnegie Mellon so special is that the School of Computer Science is not a department in the College of Engineering. Its founders had the vision back in the 1980s to create its own separate school with departments that focus on things like machine learning, robotics. It's the largest robotics research organization in the country, with about 1,000 roboticists doing research, students and faculty that do research on robotics. We have a Language Technologies Institute. I'll jump into more detail as we go through the slides here, but this is just wanted to give you a sense of how Carnegie Mellon's organized. If you can skip to the next slide, please. So our computer science department focuses on everything from artificial intelligence to a lot of theoretical, like quantum is something that computer science department does. It's privacy and security, systems work, programming language, a lot of the foundational things. When you think of computer science, a lot of the foundational work is done in our computer science department. Edge compute, this next slide gives you a sense of one of the research projects that has been taking place in our computer science department. If you could switch to the next slide, please. So this is a project called Project Gabriel. It's called Project Gabriel because the thought here is to have an angel on your shoulders. So with edge compute and wearing cognitive wearables like HoloLens and Google Glass, to be able to use them to understand the scenery around you, to provide the person wearing input on the best way to move forward. It could be from teaching people maintenance, helping them with maintenance problems, to in medical situations, teaching doctors how to use certain tools. So this is one example of the edge compute work with low latency that's taking place in the computer science department. If you could switch to the next slide. So we have an Institute for Software Research that focuses on everything from, again, privacy and security to software engineering, computer architecture, and applied formal methods when it comes to safety systems. Next slide, please. This is an example of a lab that is in our SciLab. It's a Privacy and Security Institute that spans the entire university. So there's over 20 faculty that work in this lab, over 65 PhD students working on all critical, safety critical problems and privacy research as well. So this is a virtual lab that spans the entire university. Next slide, please. So we have a machine learning department that works on all things machine learning, really pushing the barrier on machine learning, doing everything from work on adversarial machine learning to trying to optimize computation when it comes to algorithms for machine learning, working with scarcely labeled data, and explainable AI is another aspect that the machine learning department works on. Can you switch to the next slide, please? So these are a couple of problems, research projects that have taken place in our machine learning department. So everything from machine learning for scientific discovery, so using machine learning and algorithms to work on things like automated science, where the machine learning algorithms are determining what the next best science experiment is going to be. So you can have experiments running 24/7 on a cloud, in a cloud system. And then there's ethical AI, so understanding the ethics behind the algorithm. So machine learning algorithms are not just in a black box, and you can actually understand them and understand how to make them more ethical. Can you go to the next slide, please? So we also have a Language Technologies Institute that is focused on everything from text mining to question and answer systems. So a lot of the foundation for IBM's Watson was actually developed with Carnegie Mellon through our Language Technologies Institute, and everything from data mining to intelligent language tutoring. So this is a department that focuses on everything related to language, applying machine learning to that. Can you switch to the next slide, please? So we also have a Human-Computer Interaction Institute. So these are a cross between designers, psychologists, and computer scientists, all working on everything from user interface to human-robot interaction. So a lot of the faculty that work in our Human-Computer Interaction Institute work with faculty in our Robotics Institute on problems related to things like human-robot interaction. We also have faculty here. So when you think of the human in the loop in AI, we have faculty that work on things like data visualization. So being able to use data visualization to inform the person on what the best approach is on something. If you could switch to the next slide, please. We also have a computational biology department. So this is where machine learning is applied to biology to work on everything from cancer research to drug discovery to understanding the human genome when it comes to cancer research. Can you switch to the next slide, please? And then finally, our Robotics Institute, which is the largest of our 7 departments. And we have a couple of locations for our Robotics Institute aside from main campus. I'll speak a little bit about our National Robotics Engineering Center. So our Robotics Institute was founded in 1979 and works on everything from human modeling to autonomous systems. That's everything from path planning to sensing. Large data analytics lab here, working on everything from predictive maintenance of equipment for the DoD to human trafficking. We have a large computer vision group working on perception problems, everything from AR, VR, and extended reality to different perception systems, and then designing and building the robots. So many of the faculty that work on this action task are also joint with our mechanical engineering department, where you're building physical controls. Next slide, please. So there are many different ways to connect with Carnegie Mellon. Next slide, please. So depending on what your goals are, everything from recruiting our students at the undergraduate to the graduate level, all the way up to creating a large research partnership. So many times we'll work with companies to engage in capstone projects, which could be smaller projects where a team of 4 or 5 students will work with you over the course of a semester or 2 semesters to address a problem that you're bringing to us, all the way up to a research partnership where you'll have a faculty member, you'll have a PhD student working on a project that you're looking for milestones and deliverables and work to be accomplished, and the ability to license IP, technology that comes out of the research that's being done to larger scale projects that may involve many faculty and many students. So I was speaking a little earlier about our Robotics Institute. This is a facility that we have off campus. It's called our National Robotics Engineering Center. It's a 100,000 square foot facility. We have about 160 professional engineers working with faculty at this location, working on projects and on the right there is a picture of the high bay, where we have smaller sub bays where different projects take place. If you could skip to the next slide, please. So when you think of our National Robotics Engineering Center, think about projects that are very close to the prototype level. So when you're thinking technology readiness level, it's really around that TRL 7 that NREC will focus on. And I do want to say that a couple of the other companies that are here with us tonight, like Carnegie Robotics and Agility Robotics, all have ties to our Robotics Institute. And a lot of the foundation for Pittsburgh's robotics ecosystem was really born out of Carnegie Mellon and the Robotics Institute. So we're very proud of that, very proud to be a part of that. If you could skip to the next slide, please. This is actually another project that recently ended. It was our subterranean challenge, where we had autonomous robots going into tunnels and into communications denied environments to build maps and identify different materials that were hidden throughout tunnels. So this was a team that competed in that competition recently. It concluded last year. Next slide, please. So we also have a Manufacturing Futures Institute that is based out of our College of Engineering and spans the entire university. So working on everything related to manufacturing research, from educating, having workshops to educate partners to engaging in research and partners with throughout the community, including the Advanced Robotics for Manufacturing Institute, which is based here in Pittsburgh. It's a Department of Defense-based institute. Next slide, please. So these are some of the areas that the Manufacturing Futures Institute focuses on. Everything from advanced manufacturing technology, so additive and robotics, to human intelligence using things like data science to help inform the human that might be in the loop in the manufacturing system, to digital innovation, so things like digital twin and artificial intelligence and cloud compute, edge compute, wearables, augmented reality, virtual reality, digital twins. I think I had mentioned that. Next slide, please. So all of these areas in manufacturing, we really try to apply artificial intelligence to much of what we do, from additive to robotics for manufacturing, digital twins, and biomanufacturing as well. It's one that I hadn't spoken of, but very strong in biomanufacturing, and really working to help to build the future workforce in the manufacturing industry as well. Next slide, please. So these are some projects, some seed projects, recent seed projects that are shown here. Everything from on the right there with the robotic industrial arm that's doing inspection robotics, to in the middle there working on designing building materials using AI to build building materials, to on the left there using AI to automatically weld. So those are just some of the initial seed projects. If you could go to the next slide. So these next slides show worker safety projects that are underway. Everything from light curtains on the right there to tactile skins for industrial robots to make the human-robot interaction safer, to modeling and modeling performance on the left there. Next slide, please. So this next one is around digital twins. So when I mentioned augmented reality and virtual reality, extended reality, many of the faculty that work in these domains work in projects like this. So on the left there, it's showing some automatic generation of digital twins, to safety and security critical digital twins in the manufacturing realm. So these are just a few examples of some of the factory digital twin research that's happening at Carnegie Mellon. This is the off-campus facility. It used to be an old foundry in Pittsburgh. So Pittsburgh has its history in steel. So Carnegie Mellon opened this facility in 2020, right before the pandemic, and has been really growing ever since. So our Advanced Robotics for Manufacturing group is also based here, along with our researchers with Carnegie Mellon, working on everything from education and workforce development to entrepreneurship. And there are going to be other facilities going up around this building as well. So there's going to be a robotics innovation center. Industry is also going to be moving in this same area. These are just some examples of some of the additive manufacturing equipment that's found in our Manufacturing Futures Institute. Everything from the Trump F TruePrint 3000 to furnaces and laser cells. So very high tech space there. These are on the right there, the machine shop, and the left is a high bay flex lab where some of the work takes place. Next slide, please. And then these are some of the low bay and flex space that we have available that are at the moment filled with projects that are very active. Next slide. So that's a little bit about Carnegie Mellon and the work that we do. So I want to thank you all for taking the time to listen to my presentation today, and I look forward to future interactions. Thank you.
Thank you very much, Mr. Darakas. Thank you for this wonderful presentation all about CMU, Carnegie Mellon University. I didn't know that robotics and AI go way back when, back to the 1950s. Well, now I do. Okay, so moving on, ladies and gentlemen, we're now welcoming Mr. Nick DeSanti, the Business Development Manager from Carnegie Robotics, to introduce all about advanced application of machine vision technology. Sir, it's your presentation.
Everyone, I'd just like to thank you all for being here. Good morning to those in the States, and good evening to those in the States, sorry, and good morning to those in Taiwan. I'm very excited to be here today. I want to give a special thanks to Vicky's son for setting this all up and managing me as I tried to get her these slides over in a fashion that worked. So thank you, Vicky. We are Carnegie Robotics, and we are located in Pittsburgh, Pennsylvania. I believe you heard George mention that we have some roots at the National Robotics Engineering Center at Carnegie Mellon, and we do. We were founded in 2010. We actually spun out of the National Robotics Engineering Center. Some of our founders who have been with Carnegie Mellon National Robotics Engineering Center for actually decades were working on a lot of the projects, again, that George had mentioned, and had a goal and a mission really to try to commercialize these products. And our goal at Carnegie Robotics is to bring advanced machine vision, rugged, reliable machine vision to all of the off-road markets. So if you think about construction, mining, agriculture, defense, even maritime, energy, warehouse, all of these applications where you consider that you may want to use machine vision, we do that. Additionally, we have a lot of experience as well in things like GPS, GNSS, GPS denied environment, inertial navigation, etc. So thank you, Vicky, for moving on. We provide end-to-end solutions. So we are not really a one-stop shop. Really what we focus on is everything from the inception of a project or an idea that may come from one of our partners. We partner frequently with large OEMs who control the market share, own a considerable portion of it in some of those industry verticals that I had mentioned. So we'll take a problem, a very deep, difficult problem in autonomy, and we will start from scratch in designing and really engineering that autonomy. You can see there in that second photo where it says prototype and collaborate. Vicky, if you could actually just return slides, please. The most previous one. Thank you. Everything we actually build in-house as well, at least on the prototyping side of the house. So we do have advanced manufacturing as well, but whenever we have something that is in that stage, we've invested a lot of time, money, and resources into building up our test facilities. So if you can see that photo, it's a very similar sort of high bay to what you saw in the photos for CMU at NREC. And in those bays, again, there are many different types of projects going on. We are doing everything from thermal cycling, extreme vibration and shock testing, sensor obscurant testing, so dust. We're testing corrosion with salt spray chambers, et cetera. We are doing all of the testing to make incredibly rugged and reliable products. And again, that's what you see there from that in-house test. Moving along, we actually do have a low to medium rate manufacturing facility as well. So I mentioned everything is prototyped in-house, but we do manufacture all of our machine vision components that go out the door. So that being our stereo cameras, our multifunctional array sensors, some GPS systems, a lot of different things, even full-scale robots, which you'll see as I move a little bit further in the presentation. We are an ISO 9001 2015 facility. Just actually finished up our recertification. Quality is by far our number one priority. We have a very, very advanced integrated systems of record to which we control all of our, every single product that goes through the manufacturing line. We manufacture in the order of thousands. So if you were to go on our website, you would see an array of stereo vision cameras. And I'm going to get into some applications here that go through those and a couple of other products that we make to really drive autonomy in the industry. So if you could go to the next slide, please. I mentioned that we put a lot of focus on in-house testing. And what we really pride ourselves on is making the most rugged and reliable cameras on the planet. Again, our bread and butter, as I like to call it, is our stereo vision cameras. These are cameras that essentially create a depth map of the environment in front of you to be used for things like autonomous navigation. You'll see on the left one of our stereo cameras on a large haul 400-ton mine truck. And on the right, actually on our shred robot, which is Carnegie Robotics designed in a program of record, semi-autonomous mine detection robot that actually just finished low rate initial production in 2020. So these sensors are very, very reliable. They're very rugged. They perform highly. And we've spent the better part of the last decade developing these sensors for all of these advanced applications. And moving forward here, I'm going to show you just a few of those applications so you guys can kind of get a sense of the type of projects that we work on. Next slide, please. I mentioned that I'm going to explain a little bit about some of our applications and sort of the capabilities therein within those applications. And there's a very wide array. I chose a few in particular that really span across a handful of different industries, so you all can get an idea of the depth and the breadth to which we perform these autonomous projects. Next slide, please. First and foremost, we have our autonomous floor scrubber. What you're looking at is the Liberty SC50 floor scrubber from a company called Nilfisk out of Denmark. Nilfisk is one of the world leaders in floor care. They own a considerable portion of market share in the floor care space. What Carnegie Robotics does for them is we design the stereo camera and have designed and manufacture the compute box that goes inside of the system to make it autonomous. So if you think grocery store or gym, warehouse, etc., this is the world's only third-party safety certified autonomous floor scrubber on the planet. We manufacture these kits in very high volumes, to which we send out to our partner and OEM in Nilfisk, and they deploy these across the globe. Additionally, we have patents on an additional portion of the scrubber not pictured here that actually uses UV light to kill COVID-like pathogens. And I believe there's a video if you'd like to go to the next slide and share that. The autonomous floor scrubber, as you can see, it's navigating a gym here. Thank you for reducing it there. Again, this uses the stereo vision camera to map the surroundings. It has a redundant 2D LiDAR system for safety as well. This will never hit a human. Carnegie Robotics not only manufactures the kits that get installed into these to essentially map the environment, but we've also written all the software that allows this device to actually run autonomously. So all of the mapping and all of the data piping is all done by Carnegie Robotics. There are nearly 1,000 of these robots deployed in the world now, and that is scaling up very, very quickly, actually. As you can see, there are some fun features like red when it's stopping or it's angry, blue when it's satisfied and it's running. I think we can stop it here and move on to the next slide. This one is this is kind of a fan favorite. You're probably all familiar with Spot by Boston Dynamics. Spot is best known for its choreographed dances with other robots and on different sites, but really Spot has a lot of utility. And a lot of that utility that Spot has is actually driven by the multifunctional sensor on top. So if you ever see a Spot out in the field at say an energy site, a substation, etc., some sort of space where you wouldn't want a human to go, or you'd want to remove a human from danger, you would send Spot in there with this payload. This payload is designed and manufactured by Carnegie Robotics for Boston Dynamics. What you're looking at here is a 360-degree ring camera system for situational awareness, a 30 times pan-tilt zoom HD camera. Additionally, it has thermal capabilities for mapping different, or not mapping, rather, for inspecting different things on site. Say, if you have a pipe that's getting hot and you would like to either gauge the temperature or see if something's overheating. And I'll explain a little bit more here in the video. If you could go ahead and play that and actually fast forward to 30 or 35 seconds, kind of gets into the better portion of it.
At National Grid, our number one priority is keeping employees safe. Boston Dynamics Spot Robot helps us do just that. National Grid is an electric and gas utility here in the northeast of the United States. We supply electricity and gas to
places like substations, power stations, to go and inspect in areas where you'd otherwise normally have to shut down or take very extreme safety protocols and measures to make sure a human is safe. You don't necessarily need to do that with Spot. It can be remote controlled. It's going to get into a portion here. You can actually see what's called Spot Cam being activated here. So again, sorry, it's about 30, 40 seconds into this video.
Routine inspections with the maintenance team, operations team.
The Spot Robot allows us to have a closer eye on things and a very repeatable view of our equipment.
Right now, they're operating the pan-tilt zoom camera on the system.
It has a pan-tilt zoom optical camera that allows us to zoom in up to 30 times.
This is very, very useful for things like gauge reading at a distance.
It also has a thermal IR camera, which produces thermal imagery of what it's seeing, allowing us to look for any
see now, yeah, they're actually activating the thermal camera.
Anomalies in the equipment.
This allows you to see if things are overheating, as you mentioned, thermal anomalies.
Measuring around it, understanding where things are in relation to each other. We are
and that's
also
about the
testing
extent
other payloads on the robot to be able to increase its communication range and to be able to allow us to control it from.
So that last product and that last partnership that we have is to really kind of show you the depth of which we have. If you go on our website, you'll see a lot of stereo cameras and projects related to it, but really we do a lot outside of that. If you could actually pause the video for just a second, and then I'll have you play it. So I can. Could you pause the video for just a moment, please? And go back. Thank you. Thank you. Okay. So entering uncharted territory. This has been a very, very exciting project for Carnegie Robotics. Last year, we announced a partnership with Brunswick. Brunswick is the world leader in recreational marine boating. We recently partnered with them to drive autonomous functions in their fleets of luxury boats. So what you're seeing, the arrows piping out to our very ruggedized 27 centimeter baseline stereo cameras to actually provide vision to the boat to perform autonomous functions. I can't say too much about it, but you can imagine some of the things that we're working on there. And this has been very, very great because when you think of self-driving vehicles, you don't necessarily think of boats, you think of cars, but boating is an industry that is perhaps a few years behind the self-driving car industry, but very much up and coming. And the set of features that may come with an autonomous boat or a boat with autonomous functions are very, very desirable. So if you can go ahead and play the video, I think it speaks for itself, and I'll just kind of let it run here for a moment and chime in, but it really, really speaks to some of the things that we're doing. This video was released shortly after the Consumer Electronics Show last year, in which we had a dual presentation with Brunswick at. It's using the stereo vision camera and fusing data from other sensors on board to be able to help, again, perform those autonomous functions that I had mentioned. Tracking objects, using a very textured scene in rough waters to actually be able to map the terrain with pretty high accuracy. Path plan boats around it, be able to tell where they are. You'll actually see as it speeds up here, it actually path guides the boat itself. So those green whiskers you're seeing on the plot at the top are actually showing where the boat is going to go based on how quickly it's moving. So you can see if you're going to hit anything or not. Tracking objects while on the move. Again, this is a very, very exciting partnership, and it's really showing where autonomy can go. It's incredible to see, a lot of the folks that we've called upon, especially from CMU. George mentioned a lot of companies having autonomous roots in Pittsburgh, and we're very, very thankful to be right next door to and having great ties with Carnegie Mellon. Just a couple more slides. In addition to that hardware I mentioned and some of the software we write, we are working very hard on some edge compute functionality for our cameras and for our products, it's going to be kind of off the shelf ready. So what you're going to see here is just a very, very brief introduction of a ground plane monitoring and a basic object detection system. So if you can go ahead and play it. So what you're seeing in green is the ground plane. When the car drives by, you're essentially seeing in red. I know this looks very, very basic, but it's actually quite groundbreaking to be able to take all of the data, the rich data set that's being compiled on these stereo vision cameras, and be able to output something like this on board the sensor without having any additional load on your external computer. So these types of functionality are very, very important for folks that are really looking to optimize their autonomous systems, not only from sort of a load standpoint, but from a cost standpoint as well. So if you can go ahead and move on. And if you go ahead and play the video. What you're looking at right here is four actually stereo cameras piping data with very, very low latency and mapping a scene on an off-road vehicle moving at quite high speeds. These stereo cameras, as you've actually seen in the Brunswick slide as well, are meant to be used in tandem. We have a lot of experience, again, not only fusing our sensor data with other types of sensors like LiDAR, but we have a lot of experience in actually fusing the data from our own stereo cameras, calibrating them to one another, and helping to give you a real legitimate 3D view of your scene. And again, what you're seeing is a vehicle moving at speed off-road. It's banging around. It's very, very hot. Things are very, very dynamic. The stereo cameras perform very, very well in these types of environments. So if you think very, very hot, very, very cold environments, lots of shake and shock, etc., the cameras are built for that. So that's, again, what we pride ourselves on, is making the most rugged and reliable products on the planet. That's really all I had for you guys today. Thank you all for listening. I very, very much appreciate it. My contact information is at the top there, and I look forward to kind of future engagements with all of you. So thank you very much again for your time.
Okay, thank you, Nick DeSante. Thank you very much, Nick, from Carnegie Robotics. So in addition to autonomous cars, we will be looking forward to autonomous boats, where the ultra-rich folks could party on luxury boats and have them sail port to port autonomously. Thank you so much, Nick. Moving on, ladies and gentlemen, to our next presentation. Let us now welcome the speaker of the next presentation. This is the Chief Technology Officer from Agility Robotics. This is Mr. Jonathan Hurst. Please go ahead, sir. Jonathan, I need you to turn on your mic. Thank you, sir.
Thank you for that reminder. All right.
Reading you loud and clear. Go ahead, sir.
Great. I wanted to say we do have, this is an Oregon company, but we have a Pittsburgh office, and we have a pretty strong connection to Carnegie Mellon. Both Damien and I, co-founders of the company, did our graduate work there at the Robotics Institute. And I came down to Oregon State, started up a robotics program at Oregon State, in many ways modeled after the Robotics Institute in my experience there as a graduate student. And then that work led to spinning out and building Agility Robotics along with Damien. So Agility Robotics is building machines, our vision to enable humans to be more human. I think that is what everybody dreams that robots will do, by doing the dull, dirty, dangerous tasks, by taking care of the repetitive things, really allowing people and humans to be more creative, to make more decisions, to have more variety. So I'd like to run the next slide as a video, and this visually, and I think there's some sound to that, some music. I'll just let this play, and we can watch this, and I'll talk about it after it concludes. made for work. And I say that very clearly because there's a lot of robots that have been built that are really interesting demonstrations and show really cool videos. But we have a mission to build robot partners to augment the workforce, to do really useful things in the world. And a point I'd like to make here is that this is really a new category of robotics. There have kind of been a few robotics revolutions over time. The very first one is manufacturing machines, robots that are bolted down, robot arms that are behind cages because they're dangerous for people to be around. And so you design and build the manufacturing system around the robots. The next kind of revolution in robots that we're really in the middle of right now is autonomous vehicles, mobile autonomous robots, like you saw the cleaning robots that Carnegie Robotics has been working on, adding a lot of perception to it. But still, the environment is typically modified and improved for the machines to operate in them. So warehouse robots and things like that, you'll set it up for the automation system. Digit is really the first practical robot that is designed to be in human spaces, doing human-centric, human-scale tasks. And that is a future of robotics. It's going to be big. It will be ubiquitous. We will have robots in our homes and our businesses. Next slide, please. But we are starting now, in markets that matter today for things that we can do with the technology that we have. And that's things like unloading those plastic tote bins and moving them from a shelf, an automated picking shelf, to a conveyor belt, or unloading a tractor trailer. The value of having a machine like this is the versatility. The fact that so many of these tasks are built around humans doing them, and then as they scale up those operations for logistics, they can't hire enough people to do it, but it's still designed around people doing it. This kind of automation can step in and augment the human workforce without having to build additional infrastructure. It's something that already exists, and the robots can come in and do that task. And they can do multiple different tasks and not just a single purpose device. Next slide. The market is very, very big. Having robots that can do tasks and work in human spaces is going to be a much bigger market than the entire automotive industry. Looking at like the UPS and the US Postal Service, over $40 billion a year on manual labor, and that's just these two companies. And you're looking at like a FedEx facility, they're short by over 1,200 workers every night. They can't hire enough people to do this work. So we're really going to help with some of that. We have a contract in place. We have a major investment from Amazon and are continuing to scale and grow our efforts. Next slide. Now, the question that's a really valid question is, why don't these robots exist anywhere? I don't think that this is a novel idea. For 100 years and more, people have wanted automatons, have wanted robots that can operate in human spaces. One of the main reasons why this hasn't existed is we haven't, until recently, even understood how legged locomotion, how walking and running actually works. It's very common. We look around and we see humans and animals with some pretty fantastic performance, but reproducing that in a robot is a whole different story. So in this video, you see the equivalent of stepping off a curb that you did not expect, an unexpected step down. In this case, it's a piece of paper stretched over so the bird can't see it. Same with the robot. Yet your foot, as a person you're familiar with this, it's a bit surprising, but you generally don't fall. You generally recover well. Your foot just extends to the ground and you can continue forward. This is not something robots have been able to do until very recently. So this is a decade of research to understand how the birds work, collaborating with biomechanics researchers, implementing it on a variety of different robots and machines, up to the point where this is the foundation of how Digit works. This is at the base of how Digit is able to get around in the world. This is a very recent scientific understanding. That's why you haven't seen these robots everywhere for the past 10 or 20 years. Next slide. Another big piece is whole body control techniques. So you have to imagine there's over 100 sensors on the robot, position sensors and force sensors, and certainly stereo camera and LiDAR, temperature sensors, all kinds of things. Then you need to write an algorithm, an equation, that takes in all that information and sends torque commands to 26 degrees of freedom on this machine. And go ahead and play the video, so that the robot knows how to bend over, pick up a box, figure out how to grasp it and then re-grasp it, step up over some objects, figure out where it's going, set the box down, slide it in until it settles with the other boxes and nests properly. Coordinating that many different sensors and that many degrees of freedom is really kind of new and sophisticated control technology. And that's relatively unique expertise. There's only a couple of organizations in the world that know how to do this kind of thing. Next slide. So we've been looking at this for a long time. On the far left, you'll see the stickers, Oregon State, Carnegie Mellon, University of Michigan. That's from when I was actually a graduate student at Carnegie Mellon, collaborating with a professor at the University of Michigan for some of the very first work that I did on walking and running and legs. Atreus there is the machine we built at Oregon State. The lab's efforts for about 5 years and about a $5 million grant award through DARPA to demonstrate walking and running in the real world. And that machine, even though it looks nothing like an animal or a person, was able to capture those dynamics and walk and run outside over all kinds of terrain. Now we're working our way towards products. Cassie in the middle is our first product. When we were a small company, 3 people, we sold those into the academic world. And we're growing and growing now, doing useful things with manipulation and moving the boxes and totes around. We've been building intellectual property and aim to continue doing that. Next slide. But more importantly than the technology is making a useful product. And these robots are not that cheap to build because we're building them in relatively small quantities. All components on this robot, almost all of them, are custom, all designed in-house, machined in various machine shops, even around Oregon and some in California, and assembled on site in Oregon at our factory and wired up and everything. They are easy to maintain. You can unbolt an arm and put a new one on and be up and running again in 5 or 10 minutes. And there's a lot of room for improving the efficiency of our manufacturing in order to produce these at volume. We've just raised some good money. We're building a factory for these robots for final assembly, and we're attracting the right talent as we grow because it's an exciting mission and really interesting technical problems. Next slide. Now, as I mentioned, we're developing multiple use cases and applications for our customers. So we may start with one customer and one kind of workflow for moving totes or plastic bins off of a shelf onto conveyors and so on. And then step out into 2 or 3 different workflows for different customers doing that application. Then start doing trailer unload and start having more and more applications. Once we're up to 5, 10 different applications, all the time our engineers are using our API, our interface, to tell the robot what it should do in that environment and continuing to make that interface better and better. When that interface is really good and rather mature, it gets to the point where we can just open this up to third parties to be developing applications and can sell this robot to people who can then program it to do the things that they would like it to do without needing to hire our engineering team to solve that application. That's when this becomes an app store, like the Apple App Store. But it's not an app store for information like a smartphone. It's an app store for labor, for doing basic tasks in the world. And you can imagine the value of that. Having a generalized machine that can do all kinds of manual labor and have anybody out there be programming those applications. That's really exciting to us. Next slide, please. And here's where I'll finish. I know that for any technology that's really changed lives, and I've got the example here of a car, and we all drive lots of places. Cars have had a major impact on our lives. We look back and ask, what would the first cars look like? And there's a clear history associated with that. Now, technologically, cars were always going to exist. Once that technology started to happen, somebody was going to invent and create them. But the fact is, not everybody did. There were certain people and certain companies that were successful with that, like Ford. And how they did it and what those first machines looked like really shaped that whole market and shaped people's perceptions of it moving forward. That's something that I take seriously and I'm really excited about at Agility Robotics. The future, people are going to look back when they see these robots are everywhere and they're helping us and these are great. What do the first ones look like? I want them to be friendly and kind, and I want people to feel comfortable around them and safe. And we can prioritize that. We can create that world. We can set the direction there And Digit is going to be the robot that people look back to and say, these are what the first ones look like. So I'll finish there, and thank you very much for having me.
Thank you very much, Mr. Jonathan Hurst. Jonathan is the Chief Technology Officer from Agility Robotics. Yes, so don't be too surprised if you have a robot showing up at your doorstep the next time you have your UPS or FedEx box delivered to you. Okay, yes, technology do change lives. Model T Ford cars did, and robots will as well. Moving on, ladies and gentlemen, let us welcome Charles Tam for the next presentation. Please.
Hello, good morning and good evening, everyone. My name is Charles from Rockwell Automations. So today my topic is about sustainable digital productivities. So thank you for TUSA for arranging these presentations. Thank you. So next slide, please. I've been in this industry many years, and recently I can see a lot of challenge facing in the manufacturing industry. First of all, in manpower resources, especially in Taiwan, like I can see a lot of experienced engineer retired, or they are difficult to hire new engineer. Digitalizations, a lot of company, maybe the plant has been built like more than 20 years, a lot of brownfield plant in everywhere. So there are a lot of production is based on standalone machines that they are not connected, and difficult to get different data to do optimizations. And recently, a lot of new initiative like environmental protections, energy saving, like ESG is a very hot topic in Taiwan. And without digitalizations, I think it's hard for them to move forward for this kind of new initiative. And also the last challenge I can see very common, especially in the last couple of years, cybersecurity. In the old days, cybersecurity may be just about IT level, maybe just about firewall. But actually nowadays, I can see a lot of cyber attack is not just from the IT level. It may be from the manufacturing level, from the machine level, from the PLC, from everywhere. So I can see there's some challenge in the last couple of years, very common in Taiwan or even globally. Next slide, please. Through the conversations of most of my customer, I can see they are very interested in some topics, especially in these 6 topics. First, very common, they would like to get data from different kind of systems so that they would like to know what is the correlations with each others. To do that, I think the only way is to do the standardizations. And the other is about empowerment. They would like to get more insight about the data they got it from the plant, because it's very complicated. Different systems have different data. How they do, how the engineer can find out what is the real meaning and how to do the optimizations, how to improve their productions. Paperless. They would like to get more data in a reliable way. They don't want everything put it in a paper and then record it, and they would like to do it in an electronic way. So also, especially in last 2 years, COVID-19 pandemic everywhere, and so a lot of machines maybe in the States and the engineer in Taiwan, they are facing challenge like how to do it remotely support by AR. Compliance, as I mentioned, they are like the ESG topic, like the energy saving or carbon footprint. They would like to follow kind of standards, and without digitalization, they may be facing a lot of challenge. Also, like scalability, a lot of companies would like to expand their business. Unfortunately, when they try to repeat the business, even in the same country or outside of Taiwan, they find that it's really hard to expand the business and how to scale up it. So those are, I would say, it's about how to sustainable digital productivity about. And I would say to do that, the best way is to do the digital transformations. So those 6 topics are very common in Taiwan, which a lot of customers facing. Talk to me about how to do the plant better and in the future what they are looking like. So next slide, please. So first of all, I talk about standardizations. Standardizations, actually, as I mentioned, that they would like, a lot of customers say, I would like to get data from everywhere, from a lot of different kinds of systems. Like they would like, for one of the example, very common is like energy saving. They would like to do energy saving. In the old days, they may focus in particular chiller or particular production line and try to optimize it. But in the real world, in the real factory, it's not just one production line, it's not just single chiller. It may be over 10 or even hundreds of the chiller in the plant. And they would like to see what is the relationship between each chiller. What can they do to optimize it in a system way? What about in production, in different kind of product production? Is it how to optimize their energy saving? And what about in different temperature, like in summer, they are in different seasons, in summer or in winter, are they using the same kind of technologies to do energy saving? Actually, to optimize the system, or no matter it's engineering saving, it cannot depend on one single system data. So they find one system data is not enough. They would like to find other relationships. That's why standardization is a very important, and I would suggest the customer to do it. Second, about the manpower, as I mentioned, that Taiwan is facing a challenge for manpower resources. I would suggest a company like build up a company level on the library code in modular base, so that different system can repeat using the same module to build up the whole factory's program. Instead of standalone machines, different program. And the reason is I can see a lot of my customer facing a challenge is when particular expert or experienced engineer left the company or retired or the whole team gone, so their production stuck and the machines cannot move at all. So normally facing this kind of situation is because they don't have a good standardization in their company. I will give some example in next couple of slides and share what we would suggest to do. So like in the old days, the engineer may focus in particular machines or particular production line, focusing on the coding. And actually, nowadays I would recommend the owner to consider put yourself on their shoes. Let them focus on their professions, not just maintain one particular system, not just do the coding, but how to do that in a modular base so that they can keep it, like I said, build up a library in the company so that the company own the code, and so they can just like a simple configurations to do the maintenance or put a new production line. So that is what a lot of manufacturing, especially like international company, they are moving in this direction. A lot of big company like I'm working with, they are all in this direction to try to standardize with simplify all the coding without everyone just doing the coding. They focus on more detail, more value things. And next slide, please. Actually, it's about, all standardization is about enablement. Digital transformations, I think the most value is enable the engineer can do more stuff, not just repeatable or tedious job doing every day, routine job doing every day, so that they have a platform to get the engineer understand what is the real status, what is the data, what can they minimize their impact or downtime, how to let them know the insight for all the data coming. I have two examples coming up in next two slides, so that is a real example from my customer, so I can show you what we'll do in the real world. Next slide, please, Vicky. Thank you. So this is from a chemical plant. Thanks for the AI and machine learning. In the old days, we may depend on an expert engineer to see how's the machines going, how the system go. If the experienced engineer or expert, they may easy to find out what is the potential root cause, potential problems. But actually, it depends on particular engineer. I would say now a lot of my customer system, they would depends on how the system provide them real data and do the build a model so that they can do the analysis more easily instead of all depends on experience. So what happened to find the potential problem, there's like 10 data related for the whole system. Like this chemical data plant, they made more than 10 data. So AI helping them, the machine learning helping them to build a model so that they can see, that is the potential root cause, and they don't need to depend on particular engineer because the system can tell them what may happen in the futures, what kind of predictive maintenance they need to do. So next slide, please, a more detailed example for this case. Like in here, my customer doing a smart valve system, helping the chemical plant doing through the data, they think that they may related to this system. So they put it in X data in here, input to the modules, so that they can clearly find out what is the potential problem in the overall system. They can proactively know, the bedding may be going wrong in next 2 weeks, so that they need to buy the spare part, or even they know the kind of piping, they have some trouble coming up, and they can predict that, it may be need to have a downtime, so they can predictive for the downtime so that they're well managed instead of suddenly downtime and everyone run through to the system and solve the problem. So it's like the AI and machine learning helping them to monitor the status for all the equipment in this whole system. Next slide, please. As I mentioned in AR, what I said, like in pandemic situations, the engineer don't need to go to the site. They can remotely through AR to do a lot of remote support, maintenance job, so that they can save the time, save the trouble. And actually AR not just helping like kind of remote support. I will show you example in next slide. Wiki, please go to the next slide. A real example, what have been done in a factory. The engineer or operator just wear the glass, HoloLens, or even an iPad. They can simply check the status or what they should do in each area. Remind the operator or engineer to do what kind of checking they need to do, and they keep working in the plant so that they can know all the status for the machines and all is live real-time data. And when they keep working, even the piping information, what kind of chemical pipe, what kind of chemical inside the pipe, different kind of pipe, and what kind of direction. So without these AR technologies, they just walk in the site and they know they don't have enough information to make the judgment or what they can do. So you can see when they keep walking, all the machines data, real-time data showing, or even some piping under the ground, under the floor. They know what is direction, what type of piping in the factory running. So even sometimes they would have trouble going on, and they would like to see the manual. They don't need to go back to get a paper manual. Just click a button. They can see, that is how to do the maintenance job, or how to have an emergency case, what they do. So many can pop up in the glass and they can see that immediately. So next slide, please. That's my last slide. I think this the last but not the least is about cybersecurity. Especially in the last couple of years, I can see many people starting to focus in this topic, because no matter how much you invest in the automations, no matter more than 10 millions in AI or in automations, without a well-developed cybersecurity system, you may just, even the plant stop. Just go to Google. You can see a lot of example happening in last couple of years. And the attack, I mentioned that not just from the IT level. Nowadays, a lot of attack, even from the PLC level, from the machine level, just workstations in the operator through the USB port. They can see the attack will come from there. And my suggestion for cybersecurity, don't just focus in the IT level. you need to have a solution which will have a total solution combined with IT, OT, so that you can monitor all the legwork in the plant from IT level to the operation level, so that any attack coming from different level, you can fully prevent it or even know how to solve the problem, and so that they can know how to prevent the attack in the futures. So that's why cybersecurity, I would say, not just in IT level anymore, it will be a total solution combined with OT level. That is today my sharing. Thank you for everyone. Thank you very much.
Okay, thank you to Mr. Charles Tam, Country Manager of Rockwell Automation Taiwan. That was all about the next generation sustainable digital productivity, including, of course, cybersecurity, a very important issue to keep in mind as well. Ladies and gentlemen, moving on to our next keynote speaker, please let us now welcome Mr. Darren Yao. He is the General Director of Mechanical and Mechatronics Systems Research Labs from ITRI. Please, your presentation, sir.
Okay, good morning and good evening, our guests at the US. This is Jeffrey Darren Yao, General Director from the Mechanical and Mechatronics System Research Lab at ITRI, Taiwan. I'm also the professor from the National Tsinghua University Department of Power Mechanical Engineering. My specialty is on the biomass microfluidics. Since I got my degree from the UCLA 20 years ago, that's why I can be the keynote speaker here. It's my pleasure and my honor to be this speaker to introduce the overview of the Taiwan robotic industry, and also try to introduce the ITRI's robotic research to briefly talk about the current status, progress, and achievement. And here's the outline. I will start from the inspection of the Taiwan robotic industry. And also based on the past achievement and looking forward, I will give you the quick glance at the ITRI. I will use the robotic research at the MMSL at the ITRI at the end. Okay, generally speaking, in Taiwan, there are more than 100 companies form the comprehensive supply chain or ecosystem of the robotic industry. For example, Highwind, TM Robots, Foxconn developed the whole robot system, and Solomon and Delta focusing on the sensory module such as the vision module, precision motion, and also Shilin developed the actuation motor, and Syntec, Nexcom focusing on a robotic controller. The total value can be expected to USD 3 billion. And almost the 100 billion NT dollars. Although Taiwan robotic industry has the supplied ecosystem, but we are facing the global challenge as shown in the next page. Next page, please. As we know, robotic utilization is not only for automation, but also for intelligent manufacturing for several applications. Taiwan robot deployment is at the number 7 place all over the world, and various applications are emerging, such as the flexible adoption of the AMR system. Innovation applications are emerging when the advanced plan and programming, even system integration are required to fulfill the high-end test objective. However, Taiwan robotics are facing, like I mentioned, the global challenge. From the market information, 4 big companies, ABB, Fanuc, KUKA, Yuskawa, have the market share up to more than 50%. It's go up to the 56.5% in Taiwan. And the domestic company market share is only 8%. Next, please. As discussed in the previous page, and Taiwan domestic country market share is only 8%. The main reason are they have the comprehensive product line and the specific simulation software and the feasibility manufacturing efficiency. Factory layout design can be evaluated in advance and become the advantage as we shown here. This indicated that the critical concept to move Taiwan robotic industry forward to future. We have to work together and target the next generation of robotics. Next, please. Currently, we are transforming a single robot arm application to robot cell integration and to multi-robot application for advanced manufacturing. First, then establish the robotic the metaverse for intensive and extended application in various area and industry, as well as for manufacturing. In addition, we focus on the next generation robots, which cover hierarchies, intelligent architecture, robot to robot, human to robot collaboration, digital twins, automation, mobility, and self-connecting communication. Of course, green robotics is also a significant topic for the ICHI now. Next, please. Basically, adoption of the robots on manufacturing is greener than adoption of the human power because of
music 的资料库中。
And that means that utilize the low energy product, more product, and the flexibility, variety, intelligence in robust automation help efficiency will be increased. At the same time, the electricity will be from clean green energy, and we developed the robots with the adoption of high efficiency motors and actuators, lighter mechanical structure, recycling materials, high efficiency, robot control algorithm, realistic simulators. They will make the robot manufacturing greener. This is our green feature. In the next slide, I will briefly introduce the robots in ICHI. The ICHI founded in the 1973 as a non-profit R&D institution. ICHI played a significant role for Taiwan industry by developing emerging high-tech research and technology for industry, creating economic value benefit through technology R&D, enhanced Taiwan industry in the global market. ICHI have served several international offices around the world, like the San Jose at the US, Berlin and Eindhoven at Germany, and Tokyo at Japan. And in Taiwan, headquarters is at Hsinchu area, near the worldwide famous science park. And the office at the Taichung, Tainan, Kaohsiung, Taipei, Nantou. Next, please. ICHI has the variety in the research and achievement such as information, communication, electronics, and optoelectronics, material, chemical, and nanotechnology, biomedical, green energy, and mechatronic and mechanical system, which I am working for. In MMSO, we focus on the intelligent robotics, electrical, and the autonomous vehicle, additive and green manufacturing. There are around 6,000 staff with more than 100 PhD at ICHI. The most famous spin-off company is TSMC. Most of you probably know that company. Well, we will provide the service for Taiwan industry. Next, please. This slide shows our robotics research and achievement, including service robot, industry robot, and autonomous robot. We have the RD 100 award in 2017 with the exoskeletal robot that can help people walking. And in 2018, with the robotic safety scheme adopted in collaborative robots for human safety. And even for 2021, with the modular robot joined that can from different robot arm with the variety combination of the smart robot joint. All the development are based on the market need and the future trend. That means where there is the need, where we get involved. Next, please. So MMFC robots, as an expert, we have developed the robots technology in various sectors. Like the I can see means the better planning and execution capability, making the robot easy to be used. I can see reply the visual recognition and understanding what happened. I can walk, indicate robots can help the human do more things in different workspace. I can move means the robot can go to the right place and do the right things at the right time. Next, please. We have the EMIO robust controller to simultaneously control several robots and the peripheral with the feature in high accuracy. Ether CAD communication, sensorless, the compare and control. Especially the EMIO controller can perform as the calibration mechanism for robot with the laser tracker. We'll have developed an accuracy calibration algorithm with adoption of IILC, iterative learning control, that can improve the accuracy of the robot. For example, we can improve the accuracy of an ABB robot from maximum RPM error of 1.44 millimeter to 0.14 millimeter. With this, the scale of the accuracy, precision manufacturing accordingly can be implemented. Next, please. And the simulator is developed for advanced application. With this simulator, that the feasibility, manufacturing efficiency, factory layout design can be evaluated in advance. This ASIM simulator can generate a robot moving trajectory in visual environment to verify the feasibility and furthermore analyze the robot kinetics. And this simulator can be remotely assessed for broader use. Next, please. And this slide shows the AI enable machine vision, FO vision. FOV enable AI or auto derivation training integrated with the deep learning algorithm. Then FOV can be easier integrated with the robot for performing different applications. We think the straightforward way to demonstrate the AI capability in robust application is to equip the robot with the vision ability, while test the perception, object recognition, trajectory planning can be realized with AI-enabled computation mechanism. This FOV shows our achievement. Next, please. Here shows the example with the FOV automatically generate the adequate training pattern and auto labeling is implemented, and the CAD-free recognition and random bin picking. This can be utilized in logistic area for picking goods and then packaging. Next, please. Furthermore, we have developed CPS robust manufacturing cell to perform the variety of applications such as the metal grinding, polishing, drilling, cutting for aerospace manufacturing, composite weaving with the multi robot arms, and auto painting spreading. With the CPS, we can perform simulation in cyberspace to minimize the development time. In addition, multi-sensory system is also implemented and integrated. For example, force, torque sensor, vibration sensor, IMU sensor, acoustic emission sensor. All these sensors can provide system state information for optimization. The manufacturing progress for various applications. Next, please. And with CPS, we transform simple automation into intelligent manufacturing process through smart box simulation, skill learning, smart distributed manufacturing. Next, please. So moreover, we also have Navio Go, the AMR Total solution for different applications, such as in convenience store, hospital, airport, auto forklift, auto moving cleaner with autonomous mapping, localization, navigation capability. Next, please. We also have HEV AMR dissipating system for managing AMR from different supplier and with variety type. This management system adopts ROS2 as a basic framework that can support multi-brands. This system has been adopted in semiconductor packaging factory in Taiwan, and this system can be utilized in smart factory, intelligent warehouse use. Next, please. So in today's presentation, I have briefly introduced the robots in Taiwan, and each is the achievement in robotic technology and product. I think that there are many opportunities among us to create more collaboration. Thanks for your attention, and any comment and question are welcome. Thanks.
Thank you so much to Mr. Jeffrey Daranyao from ITRI. And thank you to all of our wonderful speakers for your wonderful presentation. We've learned a lot from you. Thank you for your sharing. And of course, thank you to our viewers who are joining us live streaming on YouTube right now. Ladies and gentlemen, this marks the fruitful completion of 2022 Taiwan-US Intelligent Manufacturing System and Robotics Summit. Taiwan and US should cooperate for a bigger and brighter future together. Thank you to our speakers once again. Thank you to our viewers once again. We'll see you next time. We'll see you next time. And may I remind you, we have matchmaking between Taiwan and US companies. Please scan this QR code. Yes, this is the QR code you should be scanning. If you're interested in today's speakers companies, please just scan the QR code on screen right now. Yes, scan them. Leave your inquiries, and you can contact the organizers. Thank you so much. Taiwan and US are good friends forever, good partners forever. Thank you. Have a good one. Do take care of yourself and your family because COVID-19 pandemic is still with us, and we'll see you next time.